Yeah. Good afternoon, dear students. Shall I get a response from the okay? Everybody. Any one of you just type your name. Okay, the network is also reconnected. I have included so many. Can you able to see the topic? Two students left. Till then, okay. The topic for discussion is functional dependency. And so today's topic is on parameters are the fields which are so just to avoid the bad designing of database or a table, okay, this functional dependency will be useful in a database. Okay, your voice is breaking, ma'am. That is why I was asking. Net connection. Sarah is loading. Shall I connect again? I hope I'm audible now. Yes. Shall I get it fine? Shamima is not any. Is everything fine now? Shall I give your answer? Is there everything fine now, students? Okay, fine. So we'll go for discussing the topic on functional dependency. Why we are going for learning this concept of system is we have to design the table perfectly, and we have and the fields and mapping of one column with another. For example, your semester one, two, semester eight semester. Okay, so when you write, these tables are getting updated. The values are getting updated. When you get a console mark, um, they, yeah, the network and everything is fine. WL only, AWL. What about other students? How they or Bijofrin or anyone? Okay, I'll connect with my personal network. One minute. Okay, is it fine now? Students, what about now? Any one of you, can you just unmute and talk to me? Sneha, can you just unmute and talk to me? I just want to know from your side how you from your end, whether it is clear or not. Sneha, can you unmute?
Yes, ma'am, it is clear.
Okay, fine. So the problem is with the Wi-Fi. Okay, department Wi-Fi. I'll inform them back. So functional dependency once again. So what does meant by okay? I was explaining one example. So in the COE department, every semester your values are going to be stored and the marks are going to be recorded in different tables. So 8 semesters. So 8 semester tables are going to be updated. So all these tables are interrelated, right? For example, second semester, if someone is having arrear, if you cleared in the third semester, right? So from the third semester, it should not be highlighted and it should not be like, okay, if you have cleared in the fourth semester, it should not come, right? So third semester, if you cleared some of the papers, then it should not be listed in fourth semester, right? So this is how the tables are supposed to be connected properly. And in the final consolidated mark statement, all the subjects whatever you have learned, everything should come over there for only one time. There should not be any duplicate, because some of the table contains duplicate. Because for example, first semester had arrear means, okay, second semester table definitely, if you have cleared, or the results will be uh, is it fine now? I hope, Bijo, is it fine now? Bijo, shall I get your answer? And after that, I'll continue. Yes, okay. So here comes the duplication or the repetition of data should be avoided, and in the final consolidated result printed table or consolidated table which are available for each and every student. Okay, so uh, so here the data is supposed to be table one is mapped with the semester two table, semester three table. Okay, so like that there should be a correlation. There should not be any bad designs. We should not do it here. So like that we have to create the table properly when we do the code. Okay, with the help of writing some of the if else if condition properly, then definitely it won't affect the database design. So this is how we can design the database, because who will validate the database? So when you write as per some mathematical rules, when you apply on your table, definitely you can able to validate your table that is designed properly or not. Okay, one of the mechanism, or we can say one of the concept you can apply for maintaining which is depend on which variable, is there any dependency among these tables. Okay, so like that we can do an analysis with the help of the concept when you learn about functional dependency. Okay, so but which one is depend on which one, or if the when you take some one single variable or two variables, okay, at least it should work between two. So that is why it is given like, okay, functional dependency, it is a constraint, it is a rule, right? So the rule which specifies the relationship between two set of attributes. At least you have to take two attributes and then you can compare and find out is there any dependency is between the table. And in case because some of the modules you want to add and some of the modules you are eliminating from the existing application when you go for versioning, right? So at that time, if there are some dependent variables, if you removed, it will generate an error. For example, some of the financial modules are available in EduServe, it is integrated. If this financial tables are removed, will it affect the entire process? Whether there is a dependency, any other modules are depend on this financial module. Yes, definitely there will be an issue if financial module is removed, because when you paid the fee, after that you have rights to enroll your courses. You can connect it with the faculty, you can choose the faculty, and then you can appear for examinations, and so many other things are connected, right? So financial module cannot be eliminated. Is there any dependency between this module and this module? That means in the background, okay, backside, or in the uh, part, we are relating the tables actually. Is there the table related with the financial modules or connected with any other module? Is there any dependency? Okay, so that is the application based analysis. We are, when you learn this concept, you can able to understand. So in a particular, at least you need two attributes, and then you can find out and compare and find out. You can say any attribute is depend on any other attribute. Just consider here x and y. Okay, variable x is an attribute and y is also an attribute. Which variable is depend on? Okay, so the dependency notation we use to use that is we use in mathematical way, that is an arrow mark, right? And so here also we are going to use x and y, and in between that this arrow mark we are going to use it for representing the functional dependency. If this is given, okay, so in between these two variables are an attribute, this symbol is there, there is these two variables are functionally dependent. Okay, there is a functional dependency relationship is existing between these two attributes. If it is a non-functional dependency, okay, there is only one slash just above this arrow, okay, on the arrow, okay, so I'll show somewhere. So that represent non-functional dependency. And here the left side component, okay, the left side attribute or the variable is called determinant, and the y on the right side it is called dependent. Okay, so x is called determinant and y is called dependent. Okay, dependent variable. And so what is the meaning of it? Actually, x determines the value of y, and y is functionally depend on x. Okay, x determines the value of y, and y is functionally depend on x. So that is the meaning of x goes to y, or x to y. Okay, so that's the meaning of this symbol. Okay, and this is how you have to represent. X is a determinant and y is called as a dependent. So from this notation you have understood. So how we can map this with the table? Okay, consider there is a relation. Okay, a relational table. Just consider here x and y are two attributes. Okay, that just two columns, and or we can say columns or fields or attributes or properties. Okay, like that anything you can say, or two variables considered here. How we can write the functional dependency among these two variables, that is x to y. So when you write it, okay, that is the meaning of, okay, so same way how we can put it in a table. So here in a table, x and y represent columns. Okay, so that's the meaning of it. X determines y and y is functionally dependent on x. So this is how you have to read the relationship. Okay, but in a database concept, we are not going to do some computational way. Okay, we are just going to apply some search alone. For example, like it is not applicable here in DBMS concept that we are learning here for representing functional dependency. Suppose y is given like with an equation x squared plus 5x, and x value is 5. When you substitute x is 5, y is going to 50. So this kind of computations is not, we are going to do it here. Just we are going to work on different type of searches. Okay. So see here, consider a table and it contains values like 1, 2, 3, 4. Okay, and at last 2, and y value is also 1, 1, 1, 2, 3, 5. So like that, this table is available now, and we have to find out and verify this table is having a dependency x to y. Is there variables are functionally dependent or not? We are going to find out. Okay, how we can verify. So that is the aim of this concept we are studying here. Okay, X to Y, is there any relation? So how we can find out? Actually, consider here the value of X is 2. Okay, so just consider the tuple. Tuple means which represent one complete row. So consider tuple. Okay, this is T1 and this is considered as T2. T2 value is at the time X value is 2 and Y value is 1. And you just find out is the same X values repeated anywhere in the table. Okay, so here it is repeated. When X is 2, Y is 1, and here X is 2, Y is 5. So actually this is not allowed, right? So if X determines the value of Y, then both are supposed to be equal, right? So that means if two, if here when you write this relationship between these two, it is not functionally dependent. Okay, it is not. There is no functional dependency exists between these two variable because X determines the value of Y. So what is the value of Y here in the because when you search X is equal to 2 in the table, the query will search and return what is the value of Y, 1 or 5. It will be confused, right? 1 or 5. If okay, so it is supposed to be the same value here also. Okay, what is the first value here for Y? The same value is supposed to be here. When it is there, here also 2 1 and here also 2 1, we can say X is functionally dependent. Okay, X is functionally dependent. There are multiple tables are there. Okay, for example, you have cleared, okay, someone, okay, consider someone cleared the arrear in the fourth semester, right? Fourth semester. So all tables like semester one paper cleared in fourth semester. So all other, okay, all three tables, it is supposed to be, the result is supposed to be updated with fail only, right? For a same subject code, same, consider same subject code, the result is supposed to be marked as F. But somewhere it is marked with the B, that is actually wrong, right? 1 to 3, all these three table, because fourth semester only the student is clearing. First semester arrear on one single paper, clearing at fourth semester. So all other three tables are supposed to have only marked with the fail means that is valid. Otherwise, the relationship is invalid. And the database is designed properly. There is a problem with the table and the problem with the field we used to say. Okay. So this is how you can evaluate the relationship among different table. So here also that is the same meaning. Okay, like the student is having arrear in some other table, when it is mapped with the table, here also it is supposed to be mentioned with arrear, but if it is updated, but fourth semester it is updated with the result pass. After that, in fifth semester, the subjects should not come, right, for the students. So this is how the attributes are supposed to be designed properly. So that's the meaning of it. If it is 2 and it is with one value, and here also it is supposed to be 2 and 1. So if it is not there, there is no functional dependency. X is not determining the value of Y. Okay. So now here we can say there is no functional dependency. And the next example, okay. Um, uh, Another example of computations that is given. Okay, you can able to understand more. Suppose consider the value of X is 5, okay, and Y equal to the equations of or the relationship represented as X squared. So X squared is 25. So repeatedly, another one place, X value is 5 where it is given with the 35. Okay, the relationship is mismatched. Okay, like 2 1 2 5. The same way, okay, X is 5 and Y is 25, X is 5 and Y is 35. That is an invalid relationship. There is no functional dependency exists between the two parameter. Okay. So those kind of, there are different type of functional dependencies are there. We are just now learning about whether it is functionally dependent or not. That alone we are discussing now. Later on we are going to discuss about if it is not a dependent, it will falls under which category. Okay, so that type of relationships, different type of relationships also there on functional dependency. That also will, different varieties of functional dependency also there. And the next example, this table, can you compare whether it is functionally dependent or not? 1, 2, 3, 4. There is no values which are repeated, right? So when there is an X value which is repeated, then only we have to do a comparison. If there is no repeated values, everything is unique. Everything is unique. So it is having different value. So in this table, X is determining the value of Y, and this is an functionally dependent variables. Okay. So, in general, how to give a mathematical expression for this kind of two dependent or not, that is functionally dependent and functionally not dependent. So, how we can write a mathematical expression for it? Okay. So, x to y. So, how we can say whether the variable x is determining the variable value y, and how it is functionally dependent. Okay, we are writing an if condition. If, okay, there is a mathematical expression we are writing. Just the first row is considered as T1, the second is T2, T3, T4, and the last one is T5. Okay, so like that, when you take, consider here T1 and T2. Okay, sometimes we can map it in different way also. Consider there are two rows. Any two rows when you compare, that is considered as T1 and T2. So in this example, okay, we are considering T1 as 2. Okay, I'll keep it somewhere. Okay. In this example, we are considering this row, T1 as this row and T2 as this row, which contains 2, 1 and 2, 5. So 2, 1 and 2, 5. So in this condition, okay, so how we can refer this value? It is T1 dot x, okay, and whether it is equal to T2 dot x, okay. So at this point of time only we have to write a functional dependency. When there is a unique value, we no need to write an expression. If it is duplicated or the same value is appeared over there, that means the T1 which contains the same value and one more occurrence or more than one occurrence. Okay, so that we are writing here. If T1 dot x is equal to T2 dot x, at the same time, this corresponding T1 dot y is supposed to be equal to T1 dot T2 dot y, right? So that is why we have told. If here also 2, 1, then here also supposed to be 2, 1. Then only it is functionally dependent. Okay. So all unique values are here. Okay. It may have different y value or the same kind of y value. It is not a problem. Okay. So at that time, the table is completely functionally dependent, and the dependency type of dependency is called trivial dependency. Okay. If the table contains unique value, like here the table contains unique value, and if that means the value of x contains unique value, means okay, you no need to do any comparison, no need to do an analysis, you can directly straight away say that this table is functionally dependent, and it is of type trivial dependency. Okay, and the x value contains some duplicates or the same value when it is repeated at the same, and at that time, okay, we are saying that t1 dot y and t2 dot y also same, means then only the table is, or these two variables are functionally dependent. Okay, so this is the mathematical expressions we arrived after this kind of a conclusion. I hope it is clear, right? But here it is not. Okay, when you consider these two values, okay, it is not functionally dependent. Okay. Next example. uh, okay, the same thing is given. So here it is functionally dependent because everything is with unique value. Okay, so just with the small values we have done that analysis. Now we can go to an actual real-time table. Okay, so in a real-time table, consider the table name is student, which contains columns like 3, 4, 5 columns are there. Register number, name, marks, department, and course. And we are going to find out which are the fields are functionally dependent, which are the fields are functionally not dependent. Okay. So this is the basic rule that we are going to apply for this table, and we are going to find out the answer for this query. Okay. Consider here register, roll number and name. Okay, roll number and name. Okay, to take the value, two values you just take. Okay, and or you can verify everything 1, 2, 3, 4, 5, 6. So fully it is unique. So you no need to compare with anything, and you can say Is there any functional dependency exists between roll number and name? You can directly put a tick. Okay, it is functionally dependent because there is no duplication in register number, roll number. Okay. Then second relationship we want to find out name and roll number. So you have to start here. Is there any unique value? No, there are some variables or some values are repeated. So we have to do a cross check. Here also A and here also A. That means consider this is T1 dot X and this is T2 dot X. Both are equal, right? Both are equal means, okay, go for the next conditional verification part, T1 dot Y and it's T2 dot Y. T1 dot Y is 1 and T2 dot Y is 3. So it is different. They are not equal. So we can say that it is functionally not dependent and we have to put a cross mark. And the same way register number and marks. Okay, so register number is unique. So directly can no need of comparison, directly put a tick. And when you consider department and course, so department, is there anything is repeated? You have to find out first. Yeah, something is repeated. That is CS and EE, right? And these two are repeated means, okay, then you have to compare its course value. Consider TS and CS, sorry, CS and this CS. This is T1 dot X and T2 dot X and both are equal. Now go for the comparison of T1 dot Y and T2 dot Y. These two are different. So you can say that it is not functionally dependent. Then the last relationship, what is about course and department they are asking. Okay. So here also some of the values are repeated, C1 and C2. And find out, then take the value of C1 dot X and T1 dot X and T2 dot X of C1, it is mapped with a different value. So it is functionally not dependent. So this is how you have to mark the relationship among these tables. Okay, maybe all computer science. That's the meaning behind it. All computer science department students are supposed to study. You're writing a query. Okay, so all computer science students are supposed to. Our mandatory subjects are there. Okay, is there all mandatory subjects are registered by the students? How you will verify the data? For example, CSE department first year students, first semester, all CSE students are supposed to have mandatory subjects. 5 subjects are there. Names of subjects are mandatory. Okay, in such case, 500 plus students are there. It is very difficult to find out one by one table. So when you write a query, and it is very easy to find out. Okay, so when you write a query, a search query, so this is how your search query will find out, and then it will list out. Okay, these are the records are not registered. These are the students are not enrolled for this particular subject. Then they can able to go back and they can able to find out. Or if there is any mismatch, they are supposed to register only list of 5 subjects, but they have registered one more, which is not required. Okay, so by means of writing such kind of queries with the help of it, you can find out which is related and which are the things are not mapped and not mapped. Okay, with the help of it you can able to check. So this is an example, and few more examples. So now we have learned about one variables. Okay, where that is the one determinant, one dependent variables alone we have learned. We can take more than one also, more than one variable also we can take, and we can do a comparison. Okay, here comes, okay, just consider register number and name. Okay, the register number and name. So first of all, you have to go and find out register number. So this is X and marks is Y actually. So register number, everything is unique. Yeah, definitely. Then there is no issue. Directly you can put a tick. Okay, no need to verify anything. You can directly put a tick. Okay, functionally dependent. Then this is the main set, and inside that we are forming one subset, that is name to mark. Also, okay, so the name to marks. Okay, so subset is also okay. The answer is what about the subset? Okay, when the main set is functionally dependent, the subset also be the 100% chances for functionally dependent. So name and marks when you take. Okay, so here when you take name and marks, So name is there anything is repeated? Yeah, A and B. So these sets you have to verify its value. The marks also same. Okay. That means how many students got CGPA 9? There are with the same name also, because in CSE department there are possibility for many students with the same name, right? Many students with the same name can have the chances for, or if you're doing a comparison about, okay, what about the name of the student who scored there are two students are listed, okay, like you can consider Bijofreen and Bijofreen. There are two CSE in CSE same section, okay, two different two students are there, Bijofreen and Bijofreen, and they are both got 9 CGPA, 9 CGPA. Then you have to find out, okay, so by their register number, you can able to map that, okay, so uniquely this you can say if you set your register number as a primary key, then you can successfully execute this functional dependency and you can able to find out and locate the student. Okay, so this is how which one is supposed to be unique, okay, that you have to determine and you can make it. Next, okay, so another two parameter we are taking, there are different parameter, name and marks and then department. Um, so name, marks, department, right? So you have to go for name. Name, marks, okay, already we have verified, okay, that it is functionally dependent. So you can go for definitely a tick. And the next name, marks, okay, already it is okay, but department and course you have to check now. So you have to go to department, duplicate, okay, values are same thing is repeated, CS and EE, and come up with courses, okay, it is different, EE different, CS it is different. So in this relation it is not functionally dependent, okay, so this is not functionally dependent. So this is how you have to find out which are the relationships are having functionally dependent and functionally non-dependent. Okay, so I'll just show one example question that was asked in the gate. Okay, in 2000 question, gate 2000. This question was asked. Okay, the question is like the same way you can expect a question from this topic for your internals. Okay, this is how the sample questions are based on this concept. The questions will be asked. So here you can find out, okay, question is given the following relation instance, which of the following functional dependencies are satisfied by the instance? Instance means, okay, it is an object. So consider, or we can say it's a variable or a field or a column. Okay, so the table is also given. It is with three parameter or three. It is a table with three columns. Okay, X, Y, Z, and the A, B, C, D. Four options are there, and you have to find out which is a valid functional dependency on this particular table. Okay. So first of all, you take X, Y. That means X and Y. In between X and Y, you have to do a comparison. So you have to first check X is having unique value. No, right? So three times the one value is repeated. Then you have to go for comparison with Y. All Y's are supposed to have the same value, but here it is not. Okay, one is having 4, another one is 5, another one is 6. So this case is failed, and you no need to verify the second part. Okay, so option A is invalid. Then you go for option B. Option B is YZ. So go and find out the value of Y. Y value is 4, 5, 6, and 2. Okay, it is unique. And then compare with, okay, if it is unique, definitely the first part is, you don't need to go for comparison with anything, right? So first part is valid. Then you compare with the Y to Z. That means Y value is unique and Z is okay, you no need to do a comparison. So option B here comes, you can identify the answer is correct. When you consider option C, suppose more than one options, but there is a possibility, okay, two answers are there in the for a particular question. If you want to find out, then you have to compare option C. Option C, Y, Z. So Y already we verified and Z. So this is already existing in B option. So it is over. Then, but you have to compare the second part, X to Z. Okay, so X value duplicate. Okay, one is 2, but one is 3, and these two values are okay, fine. but the first value is with a different one. So it is a non-functionally dependent variable. Option C is invalid. And so this is how option D you have to compare X and Z. So X is having duplicate, Z is having X, Z already we have compared. Right here we have compared and we have identified in option C this part. No, it is here itself failed. So you no need to verify the D first part. So you can say that option D is an invalid one. And what is the correct answer is option B. Okay. Have you all understood this question and functional dependency concept? Shall I get your answer? Yes or no? Have you all understood functional dependency? On a particular table there are different columns will be there. First of all, okay, on a relationship, okay, take the first component and check whether the component is having unique value. So unique values are there in a particular table, okay, for a particular column. When you start component comparison part, no need to do any other valuation, directly straight away you say it is functionally dependent. Okay. And then the next part is, suppose in a particular table, the first component may be presented in two another places, then what you have to do, you have to compare with its y value. The y value is also supposed to be the same. But if it is not same, okay, then you can directly say that it is functionally not dependent. These are the two rules. And the mathematical expression T1 dot x is T1 dot equal to T1 dot T1 dot x equal to T2 dot x, then you have to go for the comparison, that is T1 dot y also equal to T1 dot T2 dot y. Okay, so when you compare these combination, you can able to find out which are functionally dependent and which are functionally not dependent. So here they are asking about choose the functionally dependent option. So that is why this is how you have to find out. Okay, one more question is there. Here also you can able to find out. So here comes multiple variables. Multiple variables. This is the combination of this kind of question. Law at last we have discussed. No, at last we have discussed this part. No, like x and y is represented by name is x and marks is y. Okay, so this is how multiple variables, multiple attributes are considered for this comparison in question 1. Then the second question we are going to discuss, but here it is single variables are considered. How to, okay, here comes, you can able to read the notation for how to write a non-functionally dependent one slash also cross, okay, one line when you have given over there, it is the meaning non-functional dependent. Okay, so in this question, from the following instance of a relationship schema R of ABC, we can conclude. So here they didn't ask about find the functional dependency or find the non-functional dependency. You have to give your own conclusion about, okay, the different type of relationship that exist here. Okay, so the table contains 3 columns A, B, C, and first we have to start. Option A is A. Consider A, it contains some of the both are duplicates, right? So then you have to start it comparing with its B value. So A is here also 1 and B also same. X is same, Y is same. X is same, Y is same, X is same, Y is same. So it is functionally dependent. First part is put a tick. And then go for B to C. So B here also compare the duplicate. It is here 1, here it is 0. So it is invalid. But other two are fine. But first two sets are invalid. So option A, we used to say it is non-functional, right? Then go for option B. Option B, A to B is fine, right? It is good. And but it is non-functionally dependent. Here itself we identified. So B, you may think answer is B, but we are not giving answer as B. We go for answer as C. Because here they didn't ask you to give a conclusion. There may be possibility because you have to take a decision at this point in time. Actual answer is B, but we are going for answer is C because there may be a possibility for some of the component can go for a non-functional dependency. So here comes what is the valid non-functional dependency exist in the table. So that's why we should point out B goes to C. Okay, so in such question, you should not give the answer as functional dependency relation. Okay, you should go for a non-functionally dependent relation. So which is non-functional, that alone you have to take, which is a valid non-functional. Okay, B2C is a non-functional. When you compare the last option, it is wrong, completely wrong. First option, completely wrong. But B and C options are correct. Okay, second and third options are correct. But why we go for the C option, conclusion part, you have to take always non-functionally dependent uh, uh, dependent relation alone. Okay, so this is also one of the gate question, and you can expect similar kind of questions for your exam. Have you all understood? For my question, please give your answer and then you can leave. Okay. Have you all understood functional dependency and how have you understood the patterns of questions and how we can give an answer for finding out this kind of functional dependency? Shall I get your answer? Yes or no? Please type your answer and then leave. Thank you. If you have any questions, you can ask. No answers so far. Am I reaching to you? Students, please give your answer. Shall I get your answer? Yes, ma'am. Appa. Okay. So I hope I reach to you, reachable to you. I'll upload this video also in the Google Classroom. You can refer it. Okay. Thank you, dear students, and you may leave.